G'day, welcome back to Maths Methods with Mr. Hanna. So we're looking at linear functions, and in this video we're going to be focusing on gradient. So in the last video I mentioned that a linear function will look like this: y equals mx plus c. And there are really only three features of a linear graph, and you can see a linear graph here. And those three features are this bit here, which is the y-intercept, which of course is going to be the same as c here. And there's this bit here, that's the x-intercept. And perhaps the most important feature is how steep this thing is, which is this m, okay, and it's called the gradient. The gradient, which gives us how steep the graph is. And that's what we're trying to discover in this video. We're trying to find out what actually is that gradient. And we're going to find that the gradient, well, it's the steepness, and it would be less steep if it went further across than it did go up. So the steepness is given by how far up it goes for every stage that it goes across. Okay. So for every one that it goes across, how many does it go up? That's what the gradient is. So you can see here, for every one it goes across, it's gone up 3. Okay, so it looks like the gradient's going to be 3, because it goes up 3 for every one it goes across. But we can only do it that way in examples like this that are so easy. We need to come up with a far better, more mathematical approach that will give us the right gradient every time. So here's how we do it. We say that the gradient m is given by the rise over the run. So the rise is how far up this thing goes, how far up it goes, and the run is how far across it goes. So to do this, you can pick any 2 points you like. So let's pick this point for our starting point, and this point here for our ending point. So for our starting point, it's got coordinates x1 and y1, because it's our starting point, and you can see what those values are. The x is -2 and the y1 is 0. And similarly, at the top, it's our end point, so we're going to call the coordinates x2 and y2, and you can see that those coordinates are 0 and 6. So there we go, and I could have picked any 2 points along this whole line to choose. I just choose those two because they're our key points, our x-intercept and our y-intercept, so they are often good 2 points to choose. So what our rise actually means is how far up it's gone between our 2 points. In other words, it is the change in the y direction, change in y. So this is a Greek delta, and it means change. So it means the distance between here and here, the vertical distance between our 2 points. And similar to that is the run. It is the change in the x direction. So it is the distance between here and here, because that's the distance in the horizontal direction between our 2 points. So the change in y is given by our end point, which was our 6, or our y2, take away our y1, which was 0. So the change is our y2 coordinate, take away our y1 coordinate, and that is equal to 6 take away 0. And similar to that, the change in x is x2 take away x1, which for us will be our x2 is 0, there it is, x2 is 0, and x1 -2. So it is 0 take away -2. Alright, so now we're up to just calculating this, which is 6 take away 0 is 6. 0 take away -2 is positive. Oops, what am I doing? Is positive 2. Negative and negative make positive. And 6 divided by 2 is 3. So the gradient is 3 for this example over here, the gradient is 3. So if we're using our equation for a linear graph, well, we can put our 3 in for the m, and c we know is the y-intercept, which is 6. We can see that on our graph. So I can just write down my equation now. Plus 6. There we go. And there's my equation for that graph. So the key point is actually finding this gradient using our rise over run, which is the change in y over the change in x, which gives y2 minus y1 over x2 minus x1. So let's do another quick example. So here's another example. This time I'm only going to give random points. So this point here I'm going to say is -1 and 5. And I'll also give this point down here, which I'll say is 3 and -3. So there we go, there's 2 points that I'm giving you. We have to find the gradient. So we can say the gradient, well, that's the rise over the run, which is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So we've got to choose where our y2 and our x2s are going to be. So we've got to figure out which point here is going to be our initial and which point is going to be our final. Turns out it doesn't really matter, but let's just call this point over here our x1, y1, because it's further to the left. And this point here we'll call our x2, y2 point. Doesn't really matter, as I said, but we need to choose one of them. So y2 is our -3, take away y1 is 5, and our x2 is 3, take away x1, -1. So -3 take away 5 is -8, 3 take away -1 is 4, -8 over 4 is -2. So there we go, our gradient is -2. And you can see that because it's negative, that means downhill. Whereas before we had an uphill, which was positive. So let's just jot that down quickly. Negative gradient equals downhill. There we go. Interesting. Alright, let's just do one more example. Okay, so you know that I've said several times now that if we have y equals mx plus c, the m is the gradient part. But sometimes your linear equations look more like this. 4y minus 2x equals 10. And you're like, hang on, this isn't in the same sort of arrangement, the same sort of form as this one here. So if the question is find the gradient, we first need to rearrange so that it looks like this. In other words, we need to make y the subject. So let's get rid of our -2x by adding 2x to both sides. So I have 4y equals, now adding the 2x to both sides gives a positive 2x plus 10. Okay, now to get y by itself, we need to divide everything by 4. 2x over 4 plus 10 over 4. And now we're just neaten it up. Y equals 2 over 4 is a half x plus 10 over 4 is 5 over 2. Remember, we like fractions. Don't start using decimals. Fractions are good. So now, if we're looking for the gradient, and here it is, it's the thing that's next to x. So for us, the gradient is a half. So we can say m is a half. The gradient is a half, and we're done. That's basically all there is to it. Although maybe I should say that the gradient of a half means a not very steep gradient. So let me just do some quick pictures. Here's an m equals 1 picture. Here's m equals 2. You can see that it's quite steep. and here's m equals half. So you can see that a large number for m will give a steep slope, and a small number like half will give a not very steep slope. So there you go, there's gradient. Get lots of practicing because gradient comes up again and again throughout this course. Okay, see you in the next video.